Hello everyone, my name is Dispit Jos and today I'll be walking you through my project on how to use a PIR motor sensor with an Arduino to build a practical automation system. So what is the basic idea? A PIR sensor works by detecting the infrared energy or body heat that people and animals emit. As you can see in this graphic, when a person moves into the sensor's range, it detects this change in energy. What is a PIR model sensor? The specific sensor we are using to the HC SR501. The name PIR sensor for passive infrared sensor. It's called passive because it doesn't send out any energy. It only receives it. This technology is incredibly reliable and is commonly used in applications like security alarms and, of course, automatic lighting systems. How it works: high or low output. The output of the sensor is a simple digital signal. When it detects motion, the output sends a high signal, which we can think as a 1. When the area is clear and there is no motion, the output is low or 0. The simple on or off signal is exactly what our Arduino needs to make a decision. The sensor has three essential pins to function: VCC, out, and ground. VCC is the power pin, which we connect to the 5-watt source on the Arduino. Ground is the common ground pin, and the out pin is the signal pin, which sends the high or low value to the Arduino to tell us if motion is detected. Potentiometers. On board, there are two adjustable dials called potentiometers. The one is sensitivity potentiometer, and the other is time potentiometer. The sensitivity dial set the detection distance, which can adjust it from about 3 to 7 meters. The time dial controls how long the output signal stays high after motion has stopped, which can be set from a few seconds up to 5 minutes. Finally, this jumper allows us to select a trigger mode. One is high mode and one is low mode. High mode is a triggering mode, meaning the output will stay high as long as it continuously detects motion. Low mode is non-triggering. Once it detects motion, it says high for set time period and will not re-trigger until the time is up. Low mode is useful for ensuring the light turns off predictably. Now, let's look at all the components required for this. The first one is the Arduino UNO, which we can say that which is the brain of our system. The next one is the PIR sensor. We can say it is the eyes of our system, which cuts the inputs. The next one is a 5-watt relay module, which acts as the automated switch. The next one is a breadboard, which is used for easy wiring. Then we need say power source like a 9-watt battery and a bulb for output device and few jumper wires to connect everything. And this is the circuit diagram. This circuit diagram shows how all the components are connected. This pin mapping table clearly shows the connections from the sensor to the Arduino, VCC to 5 volts, out to digital pin 2, and ground to ground. Now I will show you a video of the real life connection. Here is our fully connected circuit. Here is the Arduino Uno board, our PER sensor, breadboard, bulb, battery, and the 5-watt relay module. And these are connected with jumper wires. At the center is the Arduino Uno, our microcontroller. All the logic is running on this board. It's powered via this USB cable. Here are the connectors for the PER sensor. The VCC and ground wires are providing power from the Arduino's 5 watts and ground pins. The signal wire is connected to digital pin 2, sending 1 and 0 to the Arduino. This is the relay module. It also gets 5 watt ground from the Arduino. The signal pin is connected to digital pin 4. When the Arduino sends a high signal to the pin, the relay clicks and closes the high voltage circuit, allowing power to flow to the bulb. And here is the bulb, safely wired through screw terminals on the relay. The relay is acting just like a normal light switch, but one that is controlled by code instead of fingers. This is our code. The code that makes this work is very simple. First, we define the pins for our sensor and relay. In the setup function, we declare the sensor pin as an input and the relay pin as an output. The main logic is in the loop. The Arduino constantly reads the value from the sensor. If the value is high, meaning motion is detected, it sends a high signal to the relay to turn the bulb on. If the value is low, it tells the relay to turn the bulb off. It's a simple but very effective if-else statement. And now for the final demonstration, as you can see, the room is still and the bulb is currently off. When I introduce a motion in front of the sensor, the Arduino receives the high signal, activates the relay and the bulb will turn on instantly. We can demonstrate the motion by waving our hands in front of the PER sensor. Okay, the motion is detected and the bulb turns on instantly. Now that the motion has stopped and the bulb turns off, the sensor's output will go low after the short-term delay we set and the bulb turns off. In conclusion, the project is a simple yet powerful example of an IoT automation system. It is energy efficient, convenient, and shows how we can use sensors to make our environment interact with us. Thank you.